Deviation is a smaller error, but it's also a much larger pain in the ass. It's the one that you actually need to be on the ball, paying attention to, because it can change much more easily and it can't be predicted. Or it can't be predicted to the same degree of accuracy. You can have a general idea of what it's going to do. Deviation is the impact that your ship's own metallic structure has on the magnetic fields within the area, and how that warps how those magnetic fields interact with the magnetic compass. So back in the day, back in the age of sail, this was not a concern because ships were made of wood and canvas and a couple of nails. So there wasn't much metal to speak of, nor did anyone really understand how magnets worked anyway. But as a result, there was no real concern about that metal interacting with the compass. Nowadays, though, a ship is 99% solid steel, with steel equipment everywhere, with computers, with tons of electricity running through them. You're having a major impact on you're sending out radio signals, radar signals. The electromagnetic spectrum is kind of doing crazy things in and around a ship, and all of that will have a impact on the compass, causing it to wobble. So let's just imagine things are kind of stabilized. The ship is moving as one solid structure. There isn't much, there aren't like electronics being operated on it. Obviously that's not realistic, but assuming that it will have some kind of magnetic field of its own like this. Meanwhile, the Earth's magnetic field, much larger but much weaker, is operating as it normally does in these areas outside of the ship. Once it gets near to the ship, though, this magnetic field here is going to impact it in some way. This is just from my basic understanding of what magnets are that looks right, but I'm completely guessing here. Point is that the ship itself is going to be impacting and warping these fields, meaning your compass that might have originally been pointing up here, well, now the field goes like that as it passes through, so maybe it's going to turn the compass to point, I don't know, that way, or maybe that way. Either way, it's going to shift it off from the true direction of the magnetic North Pole. And this isn't even to speak of if anything's operating on the ship. If there's a major change in the superstructure of the ship, if some large piece of metal is moved, if you're struck by lightning, if say some major component is welded on, or if you're just using a lot of electronic equipment, all of that can change the ship. The biggest thing that will change the magnetic field of the ship is its own heading. If your ship is heading this way, well, now the magnetic field looks slightly different and is hitting the Earth's magnetic field at a slightly different angle, causing the warping to have a different effect than it was having at this heading. So where your ship faces will also cause the magnetic compass, to change in one way or another as well. What this all means is that it's really hard to predict deviation. Ships will have what's called a deviation card, where during sea trials, they spun ship, or in other words, took a bearing off of a range, did a whole bunch of circles around that range, constantly taking bearings, comparing it between true and magnetic, so that they could quickly calculate what they could predict their deviation should be at each of those headings. Usually it changes never really more than 4%, probably more around 3% most of the time. But they will just have a list of, like, when the ship's magnetic heading is 030 or 060 or 090, its true heading will be 027, 061, 088. It'll look something like that. point is, it's extremely unpredictable. This here, true bearing, true heading was 3 degrees less. Here it was 1 degree more. Here it was 2 degrees less. Deviation changes constantly, and if anything is being operated that has a strong impact on the magnetic field, that will change the deviation as well. So while you can't ever be certain of what the true value is, you can predict it in advance, and you can measure it consistently so as to get more and more accurate understandings of what you could predict it to be in the future. Every time you get a bearing, you're probably using your gyro compass, but compare your gyro heading to your magnetic heading so that you can then compare, you can find your true bearing that you took off the gyro compass and compare it to whatever the magnetic bearing would be, because doing that will allow you to update what your deviation is at that exact heading, meaning you can get this more and more accurate. So if ever in the event that you did lose your gyroscopic compass, you could still rely on the magnetic compass, knowing that you have a generally good idea of what your deviation will be.